So what is the answer here?
Natural numbers.
Yes, the set of natural numbers cannot be a ring. So that is very sure. Now in Z6, which is the unit element? In Z6,
3.
so
No,
the
5.
number,
5.
yes, 5 is the correct answer. The number which is relatively prime to 6. So 5 is relatively prime to 6. Okay. Now the rings are isomorphic. So in this case, which rings are isomorphic?
Medical, madam.
Yes, D is the correct answer because 3 and 5 they are relatively prime. So 3 5 are 15. So we have already seen that ZR and ZS, if R and S are relatively prime, then this cross product is always isomorphic to ZRS, provided R and S do not have anything in common. In this case, Z2 and Z4, 2 and 4, they were not relatively prime. 4 and 6 are not relatively prime. 6 and 8 are also not relatively prime. So the correct answer is Z3 cross Z5. And talking of the last, the element dash is not a zero divisor in Z10.
3.
Yes.
3.
So the number which is not relatively, which is
Ma'am.
relatively prime. Yes. Yes. Come up. Okay. So I think there is no problem. Hope so. Whenever we talk about isomorphism, we have to go with, in this case, ZR and ZS. Whenever we are dealing with them, R and S must be relatively prime. That is the need. So in this case, Z3 and Z5, they are relatively prime. So this cross product, I mean direct product, is isomorphic to Z15. All right. All right. Now I would like to move for a true false kind of question. So the rings Z and 2Z are isomorphic. What do you
True,
think?
ma'am.
It is false.
True.
False. Why false? Because we have seen here the homomorphism does not obey, I mean does not preserve. The function does not preserve multiplication, and that is why it cannot be isomorphic. The very natural trend is any integer you are doubling. If you say phi of x, you will double it, twice x. So in case of multiplication, what is going to happen? Phi of y will also be twice of that. And if you take the product, if you take product phi of x comma y, product will be what? Doubled. It will be twice xy. So twice xy is not equal to 2x into 2y. That is why it fails. So they are not isomorphic. It is a false statement. I suppose you are getting me. Sure?
Yes, ma'am.
Okay. Now I proceed further. I proceed. In a ring, the multiplicative identity may be 0. What is the answer?
False, ma'am.
So this was false, and here it is true, because in a 0 ring, identity is 0. In a 0 ring, multiplicative identity is 0. So in a ring, multiplicative identity, we are saying maybe. We are not saying is. We are saying maybe. So it is true. Now every division ring is a field.
False.
False, because we want it to be commutative division ring. Is it so? Okay. And lastly, a Boolean ring is a commutative ring.
True.
Yes, it is true. It is true. And actually, it's a kind of repeated question here. You can see. Homomorphism in rings, I think you can state already fine. So there is no problem, no issue here. Now going over here. In Z4 cross Z11, we want to evaluate this. So minus 3 into 2. Minus 3 into 2, we know is minus 6.
6.
But we are in Z4. So in Z4, what will happen? We want to be in Z4. So this is congruent to what? Under modulo 4. This is our question. Modulo 4. So what should I have? So it will be 2. If I take 2, then minus 6 minus 2 makes it minus 8. And it is modulo 4. The other way speaking, you have minus 6 here. You are dividing by 4. So what do? You take 4 2s are 8 with minus sign. And that you subtract. So because you are subtracting, the sign is changed. And the answer is plus 2. The remainder is plus 2. This is what you have. So minus 3 2s are is plus 2 in Z4. I suppose you're following me. Sure. What I did? I just talked in Z4. Now let me go to Z11. In Z11, what is going to happen? 5 4s are 20. You have minus 20 here. And minus 20 is congruent to what? Under 11. So I want it to be 22, then it is divisible by 11. So let me have only 2. Minus 20 is congruent to 2 modulo 11. I suppose you are getting me. Or in case of, in this fashion, if you want to read it. So minus 20 when divided by 11, how do we divide it? So 11 2s are 22, but I need a minus because anyhow I'm going to subtract it. So this is going to be plus 2. Hope so. So minus 20 is congruent to plus 2. So what is your answer, ultimate answer? Here also you are getting plus 2 and in this position also you are getting plus 2. Followed? Yes or no?
Madam, -2 and -9 लिहिलं.
No, minus 2 is not a member of Z4. How can be? What are the entries of Z4? What is Z4? Yes.
Plus 9.
0, 1,
0, 0, 1,
2, up to
3.
3 only. So you have to answer amongst these only. So 9 is not there. Same way talking of Z11. Entries are from 0 to 10. I hope you are following me. Sure? Okay. Now I would like to move to all units in Z5. So Z5, 5 is prime. And whenever it is prime, all its entries are unit elements except 0. So what are the units in Z5? So you have to go with, in Z5, let me go like this. I'm in Z5. The entries of Z5, is it properly readable? Color?
Yes.
Okay. 0, 1, 2, 3, and 4. These are the only entries in Z5. And what you observe, every of these is relatively prime to 5 because 5 itself is a prime. So except 0, all entries are unit entries. And this we have repeated so many times. Inverse of 1 is 1. 1 ones are 1. 2 odds are 1. 2 threes are 1. I feel all of you agree with this. 2 threes are 6 and 6 is nothing but 1, which is the same as 3 twos are. And you can go for 4 fours are 16. 16 is 1. 16 is 1 in Z5. What we always do is, please keep this in mind, the answer we divide by the suffix. The answer we divide by the suffix and the remainder entry is the answer. And remainder can never be negative. Remainder is never negative. Remainder starts from 0 up to 1 minus that particular. This is what we have. Okay? Got me?
Yes.
Okay. I would like to proceed then for the next. You were asked to solve this equation and you know very well inside 12, the entries you have start from, range from 0 to 11. 0, 1 and up to 11, whatever numbers are there. So either you factorize this and check for it, or just go on keeping the value of x in this equation and see whether it satisfies or not. So very damn sure, you know, 2 and 3, they are there. They will surely satisfy this equation. And talking of the next entry, we have already done this, 6 and 11. Okay, what is 6 square? 36. Minus 5 6 are 30 you have, plus 6, meaning you got answer to be 12, and 12 divided by 12 is nothing but 0 in this case, because you are in Z12. Sure, same way you can check for 11. What 11 gives you? 121. Am I right? 11 5s are
55.
plus 6. Okay. What you got in hand? 127 minus 55. So 2 here. Oh no. I'm sorry. And 72. 72 is divisible by 12. So the answer is 0. Do you agree all? I hope you are getting me. Okay. Now I want to check whether 4 satisfies this equation or not. 4 square is 16. Minus 4 5s are 20. Plus I do have 6. So 22 minus 20 is 2. So 2 is not divisible by Z12. 2 cannot be 0. 2 is not a 0. And because 2 is not a 0, you cannot say 4 is the answer for this particular equation. So this way you need to solve it. Either you check for every entry, you have 12 entries with you. You're not going with 0. You're not going with 1. So reduce to what? 10 entries. So I hope you can do it. Followed me? So this was all the discussion of this particular. So I would like to go back now to our regular lecture. I think you followed me. This was show that the set of all idempotent elements of a commutative ring is closed under multiplication. So the set of all idempotent elements of a commutative ring is closed under multiplication. So how did you do it? This I need to discuss here. So it's a commutative ring and all the elements are idempotent, means if I have A, then A is its own square, B is its own square, and I want to show that it is closed under multiplication. I want to show that it is closed under multiplication. So what I'll do is I'll multiply A into B. I want to show that A into B is back in the set. What is the property of the set? Set contains only idempotent elements. Means if I am able to prove that AB bracket square comes out back to be AB, then that is this element is present in this particular ring. That is our requirement. So we go with AB into AB. I feel all of you are getting me. Now what is going to happen next? You need to use commutativity. Just so you can check it that multiplication is already associative in a ring, and they have given us that it is commutative also. So I can go like this: A into B, A into B. Can I say so? Actually, AB was already present over there. I can go like this. This is associativity I have made use of. Then A as it is. And what I will do is, let me use commutativity. So this will be B into BA. And then I would like to go for, is this fine? I have used commutativity. Now I go ahead with A times, in bracket, it will be B into B means B square, and A as it is. I hope you all agree. And B square is what? What is B square in this case? We are in idempotents. So I can make use of it is simply B. So I got A in bracket B A. Again, I'll use commutativity. I have A here, and by commutativity, I'm going to get this to be AB. And once again, I would like to go for associativity. So by associativity, what I'm going to get is, yes, it is going to be A into A. So A square and multiplied out by B, but A square can be replaced by A, and I got it back to be AB. So AB bracket square is back AB, means you got it to be idempotent. So this element is present in your ring. AB belongs to your ring because your ring contains all idempotents. Followed me? It was show that the set of all idempotent elements of a commutative ring is closed under multiplication. Means product of two idempotent elements is again an idempotent. So A square is A, B square is B, means A and B are idempotent. The product is also idempotent, means if I square AB, I should get back AB. So we have shown by a series of steps, and we showed that AB belongs to our ring. Means AB is also an idempotent element. Followed me? Okay, only one response. All right. So this will be your homework. The last question, question number 5, will be your homework. Please take a screenshot of this. Ready for the next? Okay, okay. So I stop share here, and I would like to go back to my usual thing. Okay. So up till now, we were discussing about the terminologies in ring theory. Now, one more terminology I want to add to our lecture, that is characteristic of the ring. I would like to increase font. Yes. So what do you mean by characteristic of a ring? So basically, what do you mean by a ring? Ring is a set along with addition and multiplication. What next we know? The set along with addition is an abelian group, that's all. Multiplication is binary, associative, and distributive over addition, that we know. Now, in addition to that, see here, what is the definition? If for a ring R, a positive integer n exists such that n into a is equal to 0 for all a belonging to the ring, if you know any natural number, positive integer means actually natural number. So if you know any natural number such that natural number into every entry, every element of your ring becomes 0, then that positive integer is said to be characteristic of that ring. Now, if such characteristic of ring does not exist, if there is no such positive integer, we say that the characteristic is 0. Now, let us go to Z5. What is our Z5? It contains 0, 1, 2, 3, 4, end. Okay. Now, what is that number? What is the smallest positive integer by which if I multiply here, I'll get the answer to be 0? That is the question. So up till now, you have prepared the table of Z5, multiplication table of Z5. And you know, no two entries if I multiply of this set, answer is 0 unless I multiply by 0. That is damn sure. If you multiply throughout by 0, answer is going to be 0. But we don't want 0 because we want positive integer. So what is that number? So it's damn sure that the number will not be amongst these. Neither it will be 1, nor 2, nor 3, nor 4. Then from where should I start? I should multiply by the next number. Immediately next number, that is 5. So 5 zeros are 0. 5 ones are how much?
0.
0. 5 twos are
0.
okay. 5 threes are
0.
still 0. And 5 fours are
0.
so we are in Z5. We are in Z5, and what we observed, if I multiply throughout by 5, immediately I got the answer to be 0 in every case. Now, is this the only integer? No. If I multiply by 10, still the same kind of thing is going to happen. 10 zeros are 0, 10 ones are 10 means 0, 10 twos are 10 twos are how much?
0.
Yes, 10 twos are 20 means 0 because if I divide by 5, the remainder will be 0. 10 threes are
0.
and 10 fours are is also 0. So what are the numbers? Yes, very good. What are the integers, positive integers by which if I multiply every element, the answer is 0. I get them to be 5, 10, 15, all multiples of 5. Is it right? And so on. There is no end. But I want the smallest of all. What is it? 5. So what is the characteristic of Z5? 5. What is the characteristic of Z5? 5. Because if I multiply by 5, all the elements vanish. Product becomes 0. Followed me? Okay, very good. Anjali? Pradnya? Okay. Okay. Now I would like to go next. Then the example here shows if I talk about Zn, it is damn sure because when I divide n by n, answer is always 0. Remainder is always 0. So in case of Zn, we are not differentiating like n is prime or not. For every n, the characteristic is n. Now the question occurs, in the ring Z, what will happen? What will be the characteristic of this Z? So you know very well in case of integers, what are the integers with us? 0, plus minus 1, plus minus 2, plus minus 3, and so on. As far as we are dealing with integers, we can list the things. So here you can visualize there is no natural number by which if I multiply these entries, the answer will be 0. This is not possible. So characteristic of Z is what? 0. Now if characteristic of Z is 0, you know Z is subset of Q. What will be the characteristic of Q? 0. That of R, 0. That of complex, 0. Are you following me? Characteristic of integers, rationals, reals, complex, that all will be zeros. I hope there is no natural number by which if I multiply to all the integers, the answer will be 0. There is no fixed such natural number, and that is why we say characteristic of Z. I would like to write characteristic of Z is 0. Characteristic of Q is 0. Characteristic of R is 0, and that of C also is 0. Okay, now I would like to proceed for the next, but I want all those things written in your notebook. Now, how would you go on trying for multiplying by a natural number to all the entries and all? This is rather difficult for us. So what do we do is we make use of the fact that any n times any number means we will always go with the ring with unity. In case of ring with unity, the thing becomes quite easy because every element of a ring can be written as a into 1 is equal to a. This is the basic fact. Every entry can be written as a into 1. So we will make use of this particular fact, talking about the characteristic of a ring. See, let R be a ring with unity. If n into 1 is non-zero for all natural numbers, then then R has characteristic 0. But if n into 1 is 0 for some n, then the smallest such integer n will be called as characteristic of R. So if n into 1 is non-zero, then surely n into a is 0. Just a minute. We can write a as a into 1 and you multiply by n. So n in bracket 1 into a. N into a is what? You can write as n times 1 into a because this is, written as 1 into a also as far as multiplication by unity is concerned. So here you can have by associativity n into 1 and multiplied by, do you follow me? I repeat my statement. See, since 1 is the unity of that ring, I can write every element A as either A into 1 or 1 into A as per my need. Now, what I want to talk about, I want to talk about characteristic of that ring. And who decides the characteristic? Multiplication by n. If it vanishes, then we say that particular n is the characteristic. So n into A will be equal to n times 1 into A. By associativity, I can write n into 1 into A. But if n into 1 is non-zero, then this particular cannot vanish. Under what circumstances? If n into 1 is non-zero. If n into 1 is non-zero, then this product cannot be 0. And the same thing we will discuss here, n into A, meaning n times 1 into A will be 0 only if n into 1 is 0. I hope all of you agree with me. So this will actually help us. Otherwise, it will be tedious. Just go on multiplying all the entries by n. That will be tedious. So we try it with the unity of that particular ring. So have you followed my statements? Should I repeat? Am I properly audible to you?
Oh, madam.
Okay. So once again, I would like to repeat the thing. See, I want to talk about the characteristic of a ring, but I know my ring contains unity. By unity, what I mean? There is an element 1. If I multiply by 1, my element remains the same. A into 1 is A, whether it is multiplied by 1 to the right side or to the left side. Followed? Okay. Alright. Now I want to talk about the characteristic of the ring. Who decides the characteristic? So here you are watching every entry we multiplied by that particular number. We went on. We would have tried with 6 also, 7 also, but we directly jumped to 10 because we knew the answer. And so on. And amongst these, the smallest of all was 5. So we said that the characteristic is 5. We said the characteristic is 5. Okay. Now, in general, whenever we are talking about the ring, we have to multiply each and every entry of the ring by a natural number. And you just go on trying with the natural numbers and then you'll search for the smallest such natural number. So it will be tedious. And there we are using the fact of multiplicative identity. Because we have multiplicative identity 1, we can write any entry of the ring as A into 1 or 1 into A. Now, if I know that n into 1 is not 0, then damn sure n into A cannot be 0. By just knowing n into 1 is not 0, I come to the conclusion that n into A is not 0. How? Because I'm able to write A as 1 into A. Using associativity, I'll write it as n into 1 into A. But n into 1 is not 0, so how this product will be 0? Not possible. Are you following me now? Okay. So if n into 1 is a 0, then in that case, this n into a will also be 0, and this will be true for every a because there is no concern to a. It depends only on 1. So if n into 1 is 0, I can directly conclude that n into a will also be 0 for every a. And that is sufficient for me. And thus, I can decide that this n might be the characteristic. And all such n's I can record and see which is the smallest of all. I hope now you followed me. Sure? Okay. Okay. Doesn't matter. I would like to proceed then. I would like to proceed for these questions. Find all solutions of this equation in Z12. Can you do it? Yes. Can you solve this? Okay, I would like to go with the first question. We are in Z12, never forget. I will take x common out of this as I do usually. I say x square minus 2x minus 3. Can I do so? And right side is 0. Okay. Now I can guess for the factor because I know 3 can be written as 3 ones are 3. I'll take minus 3 and plus 1. What is the product of minus 3 and plus 1? Minus 3. Yeah, and the sum is minus 2. So I hope I'm quite clear here. Product of x minus 3 and x plus 1 is going to be this particular bracket and outside multiplied by x. This is the factorization. And my question is, when this factorization will lead to a 0, what are those x's in Z12? I hope you can search for this. You can search for the elements in Z12 which satisfy this particular. If I take 4, I'll be getting 4 into 4 minus 3. How much? 1 into 4 plus 1. What is the answer? 4 5 is 20. Is a 20 equal to 0 for you? No. 20 is not a multiple of 12. 20 is not in the table of 12. So taking 4 was a wrong thing for me. X equal to 4 is not a solution. Hope so. Now, if I take x is equal to 3 directly, I'm indicating over here. If I take x equal to 3, then damn sure the answer is going to be 0. Do you agree? Okay. Now what this indicates you? What is the, yes? So if we take x equal to 3, what you will get? 3 into 0 into x plus 1 means 4. So the answer will be 0 by taking x equal to 3. Same way, if you take x equal to 11, what will happen? 11 into 11 minus 3 into 11 plus 1. What is 11 plus 1? 11 plus 1 will be
12.
12
0.
and 0. So you got the answer this way. Is it so? So I hope you'll keep trying with the members of Z12. Sure? Can you suggest me any other answer?
X equal to 8.
X equal to 8, if you take, what is going to happen? This will be 8. Come on, this is 5. And this will be 9. Yes. So 8 nines are 72. And 72 is divisible by 12. So surely this is your answer. Very good. Very good. Anything else? Come on. So we have noted here x as 3, x as 11, x as 8. Anything else? X at 0 will do. X at 0. Yes. Anything else? So let me just go on listing the values of x. 0 is there. 3, 8 and 11. Yes. Is there any? Factorization helps you in counting it, isn't it?
9.
9. 9 will it do? 9 into 6. Okay, and 10. Will it do? Yes, surely. 6 twos are 12. Yes, very good. 60 you are getting. Yes, you are right. So x equal to 9 is also one of the answers. Okay, anything else then? Huh? So these are the only answers with you? Is this right? Yes. Okay, very good. Now the second question, 3x is equal to 2 in Z7. 3x is equal to 2 in Z7. All of you know what are the members of Z7, under what conditions it is going to be 2. That also you know. Answer should be 2 more than the table of 7. Anna. So 14 plus 2, 16 answer. Will you get ever 3 into anything is 16 is not possible. Then 23, is it possible? Just try with the entries in Z7. Come on, 3 ones are 3. So 1 is not possible. Then what? 3 twos are 6. Not possible. 3 threes are 9. Is it possible? Is 9 2 more than or 9 minus 2 divisible by 7? Is it divisible by 7? I hope you can read the equation as what? 3x minus 2 equal to 0. So 9 minus 2 is a 0. So this is a solution. For x equal to 3, you got the solution. Are you following me? Only one response. Okay. Now, if I go for 4, 3 fours are 12. 12 minus 2 is not 0 in Z7. What next? 3 fives are 15 minus 2 is not possible. And 3 6 are 18 minus 2 is not possible. So the only answer with you is x is equal to 3 in Z7. Oh, you followed me. Same way you need to do it in Z23. How many entries are there in Z23? In all, there are 23 entries. Out of 23 entries, 0 and 1 will not work like this because 3 into 0 minus 2 cannot be 0 in Z23. 3 into 1 minus 2 cannot be 0. So you have to talk about the remaining 21 entries. I hope you'll try that way. Okay, so as far as Z23 is concerned, I want answer from you. Will it do? Okay. So you will work for Z23 and the equation is 3x equal to 2. All right. So I think this is very interesting. Now, talking of x square plus 2x plus 2 equal to 0 is also quite easy. X square plus 2x plus 4 equal to 0 in Z6 is also quite easy. I hope you agree with me. And I'm interested actually in solving these questions. You are required to find the characteristic of the ring. 2z. 2z means only even integers. So what will be the characteristic of that ring? Huh?
0.
Yes, of course it will be 0. Yes, very good. What about z cross z? What is that entry if I multiply by it? The answer will be 0.
0.
Obvious 0. What about z3 cross 3z?
3, 0.
No. The entries are of this fashion. Z3 means either 0 or 1 or 2. I know. But the entry here will be an integer. And all the integers cannot be made 0. These are all tries of the integers, isn't it? So there is no single natural number which will make the entries 0. This is not possible. So characteristic is again 0 here. Okay. What about the next one? Z3 cross Z3?
3.
Yes, very good. What about Z3 cross Z4?
3, 4.
As far as Z3 is concerned, its characteristic is 3. And for Z4, characteristic is 4. How would you combine these?
12.
You need to take the LCM of these two, 12. 12 times the number will be certainly 0. What about this? Z6 and Z15?
90.
Z6 and Z15 I said.
Z6 the 6 and Z15
Very good. Z6 will have 6 and Z15 will have 15. We want the common thing to be. So we want common multiple of these two. What is the common multiple?
3.
30. Common multiple will be 30. 3 will not work. We will have to take the LCM. Is it okay? I hope you'll try in your notebook. Write in your notebook and try for this. Whether to take GCD or to take LCM. Okay? So the answer is this. It is with you. And I would like to deal with this as a last question. R is a commutative ring with unity and characteristic given is 4. You are required to compute a plus b bracket raised to 4 and simplify it. So you can see, okay. So what is the expansion? Okay, this is the expansion. What do you observe? A raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. This is the expansion of a plus b raised to 4. Okay, this you all know. But the characteristic is 4. Means if I multiply any element by 4, the answer will be 0. So naturally I had 4 times something. Means this will vanish. The answer will be 0 here. This is again 4 times something. That also I can write as 0. Do you agree for this? If I multiply by 4, the answer becomes 0. So here it was automatic 4 times. This is also 0. Okay. Now, a raised to 4, I can't guarantee. Okay. B raised to 4, I can't guarantee for this. But 6, I can bifurcate as 4 plus 2. So 4 times whatever I get is a 0. What I'm left with is only twice a square b square. So what is the simplification? A raised to 4 plus twice a square b square plus b raised to 4. Followed me? Characteristic was 4 means if I multiply any entry by 4, the answer will be certainly 0. So we have just to see which are the multiples of 4 and that many we have to write as zeros. Are you getting my point? Okay. I would like to deal with this and then I'll stop. A plus B bracket raised to 9 and the characteristic given is 3. Characteristic is 3 and a plus b is raised to 9. So let us go with the Pascal's triangle. What is my Pascal's triangle? This was 1, 2, 1. Then I have 1, 3, 3, 1. Then I have 1, 4, 6, 4, 1. That is what we used just now. Then we have 1, 5, 10, 10, 5, 1. Next we have 1, 6, 15, 20, 15, 6, 1. Next we have 1, 7. The sum is 21. Here I'll get 35. Again 35. Then I have 21, 7 and 1. Next let us go. Is 1, 8. Then here it is 28. What next do you get? 56. Here it is 70. This is again 56. What next do you have? 28, 8 and 1. And last is the result you want. So you have 1, 9. Then 28 plus 8 is what?
36.
Yes. Then 28 and 56 you want. So this will be 70. So 84. Is it so? Yes. This will be 126. Again, you'll have 126. And same things, just go on repeating. This will be 84. Am I writing properly? 36, 9 and 1. Do you all agree? Okay. Now what is going to happen? Whenever I write a plus b bracket raised to 9, sorry, okay, then I have just to go very sequentially with these coefficients. So a raised to 9 will be certainly there. What was the characteristic? Characteristic was 3. So multiple of 3 will automatically vanish. So this entry is going to vanish. 36 is going to vanish. 84. This will vanish. This will vanish. This will vanish. All the entries have gone. And what is the answer with you? Followed me? All the multiples of 3 are 0. All the multiples of 3 are 0. So 9 will be 0, 36 will be 0. Every of these will be 0. Only you have to test whether it is divisible by 3 or not. Followed me? Yes or no? See, what will be the second entry? This was a raised to 9. I would like to change the ink then. It's better. If I go with this a raised to 9, here it will be 9 times a raised to 8 into b. Do you agree? What will be the next term? 36 a raised to 7 b square plus and so on. Who is playing role over here? Neither a nor b, but the coefficient. If the coefficient happens to be a multiple of 3, then it will be certainly 0. So 9 times a raised to 8 into b will be certainly 0. Because by characteristic, what I mean, if I multiply by that number, by the characteristic, the answer is 0. 9 can be written as thrice 3. 36 can be written as thrice 12. I hope you know this very well. So if at all the number is divisible by 3, the answer is going to be 0. So you can see all of them, they vanish. And what you are left with is only the first and last term, a raised to 9 and b raised to 9. Okay? All right. So I suppose you can solve this one also. Here they have given the characteristic to be 3 and they are asking you for a plus b raised to 6. And the last question is, show that this matrix is a divisor of 0 in M2 of Z. Of Z means what? Matrix entries are integers. Maybe they are negative, positive, all kinds of integers are allowed here. So what you need to do is you need to find a matrix. If I multiply these two matrices, the answer will be 0 matrix. So this question you are supposed to do. Find out a matrix 2 by 2 matrix with integer entries so that the product of the matrices will be a 0 matrix. So this is your homework for today. And with this, let us stop.